If you're studying MCAT organic chemistry reaction mechanisms, feeling confused or feeling like it's overwhelmed, you're not alone. Today, I am going to simplify the most important mechanisms you must know for the MCAT clearly and step by step. By the end of this video, you will confidently understand these essential mechanisms: SN1, SN2, E1, E2, nucleophilic additions, electrophilic additions, aromatic substitutions, and redox reactions. So let's dive in. The first mechanism we'll talk about is SN1 reactions. SN1 reactions are substitution reactions that occur in two distinct steps. Here is a step-by-step breakdown. The first step is the formation of a carbocation intermediate. This is also the rate-limiting step. The second step is the nucleophilic attack. This is the fast step. The key concepts to remember are: first, it is based on the carbocation stability. Tertiary is more stability and favored compared to secondary, and primary is least. Polar protic solvents stabilize the carbocations, and it forms a racemic mixture. Always pay attention to the carbocation rearrangement. The MCAT loves testing your understanding of the stability. The second mechanism we'll look at are SN2 reactions. Unlike SN1, SN2 reactions happen in a single concerted step. The nucleophile attacks from the backside. The leaving group leaves simultaneously, so that's what concerted means. Key points to remember are, first of all, steric hindrance. Methyl is preferred because it has less steric hindrance, then primary, then secondary, and tertiary actually doesn't react because of the steric hindrance. Polar aprotic solvents are going to favor SN2, so acetone and DMSO are pretty common. There is a complete inversion of the stereochemistry. Keep in mind, SN2 never involves carbocation formation. Watch out for this subtle distinction between SN1 and SN2. The next mechanism that we'll look at are E1 reactions. E1 stands for elimination that is unimolecular. It's similar to SN1 and it involves two steps. The first step is the carbocation formation, and this is the rate determining step, just like in SN1. The second step is the deprotonation and double bond formation. Key points to remember: it favors tertiary substrates, again, just like SN1. It also favors weak bases and polar protic solvents. And don't forget about Zaitsek's rule. The more substituted alkene is going to form. Make sure that you understand that E1 competes with SN1. The MCAT is going to test your understanding of conditions that favor one over the other. The next mechanism is E2 reactions. E2 reactions are bimolecular elimination reaction. They happen in one concerted step. The base is going to remove a proton as the leaving group departs simultaneously. Key concepts to remember: strong bases favor E2. Think bulky bases especially. It requires anti-periplanar geometry, anti-geometry, and there is no carbocation intermediate. The MCAT frequently tests the stereochemistry, so make sure that your leaving group and your hydrogen are actually anti. The next mechanism that's really common is nucleophilic addition. This is commonly seen with aldehydes and ketones reacting with nucleophiles. Nucleophile is going to attack the electrophilic carbonyl carbon. It's going to form a tetrahedral intermediate. Protonation then leads to an alcohol or another functional. Some common examples are Grignard reagents, the organometallics. Also, you'll see this in hydride reduction with NABH4 and LiAlH4. Always watch the order of addition and protonation. Small details really matter here. The next mechanism that's common is electrophilic addition. This is an important reaction mechanism with alkenes and alkynes. The electrophile is going to attack the pi bond, forming a carbocation. The nucleophile then attacks the carbocation. Examples of this mechanism to know are hydrohalogenation, so HX, hydration, H2O and H2SO4. Make sure that you also know the Markovnikov rule versus anti-Markovnikov very, very clearly. The next mechanism is aromatic substitution. Electrophilic aromatic substitution, or EAS, is going to replace hydrogens on benzene ring. It leads to the formation of a sigma complex. This is your carbocation intermediate. And then deprotonation is going to restore the aromaticity. Some examples are nitration, sulfonation, halogenation, the Friedel-Crafts, alkylation, and acylation. Make sure that you're paying attention to activating versus deactivating groups and directing effects. They are frequent topics on the MCAT. The next mechanism is redox reactions. Redox reactions on the MCAT are going to involve oxidation and reduction of organic compounds. Know these common oxidizing agents. You've got KMNO4, CrO3, and PCC. Those are the three most common. And then your common reducing agents are LiAlH4 and NABH4. Some examples are alcohol oxidation to an aldehyde or a ketone or a carboxylic acid. You also see the reduction of aldehydes to ketones or alcohols. Make sure that you know exactly which reagents produce what products. These specifics are often tested on the exam. So quick recap: SN1, SN2, E1, E2, nucleophilic addition, electrophilic addition, aromatic substitution, and redox reactions are your must-knows. These are the highest yield mechanisms. Practice drawing these mechanisms frequently. If you found this valuable, make sure to subscribe for weekly MCAT strategies and drop any organic chemistry questions that you might have below in the comments. I'm here to help.